Welcome to CS 1401 video 4.2. In the previous video, I talked about programming languages, and in this video, I'm going to start talking about programming environments. That is, ways to make programming easier. Now, programming really early computers was not easy at all, and early computers were programmed, if you like, by setting switches for the individual bits one at a time. That is, each instruction was entered in machine language in binary form. Here's a picture of an Altair computer, which was a kit you could buy and use for home computing. And if you look at the front panel, you can see the switches by which you could set the individual bits of each instruction, and you had to do that for each instruction in your program. Well, another way of entering programs was by entering them on punch cards, which are called Hollerith cards. Here's an example of a Hollerith card for a statement in a language called Fortran, which was a mainstay language for computing of all kinds for many, many years. Input and output could be by punch card, but later on it could also be by teletype. And by teletype, I mean a physical teletype with a roll of paper and a keyboard, and you could enter information into the computer by pushing buttons on the keyboard, which would print out on the paper, and then when you got output from the computer, it also came out on the roll of paper. And I programmed in a language called BASIC on a teletype very similar to this. Well, that wasn't very convenient, and eventually they developed a electronic equivalent of that, and we can refer to these as basically glass teletypes. And here's a picture of an early terminal which could be termed a glass teletype. This was called an ADM5, and it basically functioned like a physical teletype with characters that scrolled up the screen as you typed or as the computer sent information back. So how did programmers using teletypes or glass teletypes enter programs into the computer? Well, they did it with a text editor, and basically it's a program that let you manipulate characters and write your program. A very powerful early text editor was called TECO, T-E-C-O, which stood for Text Editor and Corrector. And what was really great about TECO was that you could extend it by defining sequences of commands or key presses, and that's called extension via macros. Today we have keyboards, pointing devices, and graphical user interfaces, all of which makes entering programs a lot easier. And I'll show you some examples of that. More modern editors include the editor VI and the editor Emacs. And what's interesting about Emacs, by the way, is that Emacs was originally implemented using TECO macros. And VI and Emacs represent different cultures of how to write programs. VI, I would say, is typically used by people more oriented towards systems programming. Emacs is often more used by people oriented towards writing applications or maybe artificial intelligence. There's a continuing battle, a long-standing battle between users of VI and Emacs about which is the right one. And for an amusing perspective on this, take a look at the Wikipedia article entitled Editor Wars. Well, just being able to edit a program is a big step forward, but there's so much more that a computer can do to support programming. And modern programming is typically done in an integrated development environment, or IDE for short. An IDE usually has a source code editor, like VI or Emacs, but typically this is designed for the particular language for that IDE. It's got tools for calling the compiler or the interpreter to compile or interpret the program we've just written. It's got support for debugging. That is, typically, especially for complex programs, and pretty much all my programs, we never get it precisely right the first time, and so debugging means to fix the problems that we've got, and good IDEs have support for this. And in some cases, the IDE has access to the compiler or interpreter directly. Whether you're on your own, editing and compiling by yourself, or using an integrated development environment, programming is typically done with a cycle that's something like edit, compile, and run. That is, you write the program with an editor, you compile it, and then you run it. So for Java programs, which is what we're going to be programming in first, we can write the Java program in a text editor and then run it from the terminal command line. Here's an example of a very simple Java program called Welcome App. And I don't need you to pay attention to all the details of this program at the moment. They involve some of the difficult things for beginners to learn about Java. But what I'm showing you is the program as I wrote it in the Emacs editor. And my version of Emacs is called Aquamax, which is available for Macs. So I wrote the program in Emacs and saved it in a file called welcomeapp.java. Then at the command line, I went to the directory where my program is stored, and that directory is called CS1401. And if we look in the directory, sure enough, by listing the directory with the ls command, I have the program called welcomeapp.java. Now the next thing I do in my edit, compile, run cycle is to compile. So I call the Java compiler, and I do that by writing JAVC, javac, and then put the file name welcomeapp.java. So I run that, and if we then look at the set of files again, we can see that we've got a new file called welcomeapp.class, and that's the compiled version of my program. So now we can run it. We're at the last part of our edit, compile, run cycle. So I call the Java runtime environment by typing Java and then the name of this program or class. And I run it, and it prints out welcome to CS1401, which is just what I wanted. Let's look at another example of a simple Java program, and in this case I've implemented the body mass index calculator that we were looking at in pseudocode over the last few classes. So here my program is called Calculate BMI App, and again we don't really need to concentrate so much on the details of the program, which might be a little confusing, but a lot of it has to do with how to get information in and out and so forth, and we'll cover that soon enough. But the point is that I've written the program in Aquamax, and I've saved it to a file called calculatebmiapp.java. So let's go back to the terminal, and if I look at the files, I've got my welcome app program and its runtime called welcomeapp.class, and now I've got calculatebmiapp.java, which is my new program. I call the Java compiler javac calculatebmiapp.java, and that works. And now I call the Java runtime system, and by saying Java calculate BMI app, and sure enough, it starts running and it asks me to enter my weight in pounds, and I type in the number 174 and hit return, and then it types in enter height in inches, and I type in the number 72 and hit return, and it returns by printing out your body mass index is 23 point something, which is what we expect to get, and then it gives me my prompt again showing that the program is terminated. And that, in a nutshell, is how to do the edit, compile, run cycle in Java using a text editor and the terminal. One nice thing about Aquamax is that it does provide language support for Java. As we can see in this example of Calculate BMI app, different symbols, different tokens are presented in different colors, and so we know, for instance, that names of things like methods are in green and keywords are in purple, and variables are in orange, and so forth. And it helps us maintain correctness of the program. A more integrated way to do this edit, compile, run cycle would be with an integrated development environment. And I'm going to show you 3 examples of IDEs for Java. The first is BlueJ, which is available at bluej.org. And BlueJ is a free Java development environment designed for beginners. Another one is called Dr. Java. It's available at drjava.org. And Dr. Java is a lightweight development environment for writing Java programs. It's designed primarily for students, providing an intuitive interface and the ability to interactively evaluate Java code. And the third IDE I'd like to show you is called Eclipse, which is available at eclipse.org. It's a full-featured, customizable collection of integrated tools, and it's really at the pro level. However, most of our students at UTEP, I would say, past CS 1401, use Eclipse for their programming. I should mention, in addition to integrated development environments, there's also something called version control systems. When we have complicated systems with multiple generations, it's sometimes tough to keep track. Well, it's often tough to keep track, and a version control system lets you do that. Well, that's it for today. I look forward to seeing you in our next class, and until then, have fun.